Hello, class. Today you will do a polar investigation that will involve a packet as well as a graphing calculator. To get started, we're going to do the first example that's in your packet, and that is graphing the equation r equals 2 cosine theta. So for this first example, we're going to do it by hand, and then after that, I will teach you how to make this a little bit quicker with the calculator. So looking around the unit circle, we are approximating some values for 2 cosine theta, and this is essentially plotting several polar coordinates, and then we'll connect those polar coordinates and it will create a picture or a graph. We can do this by using the unit circle or by approximating on our calculators. Just make sure that your mode in your calculator here is radian. So when I evaluate the theta value 0 for this particular polar equation, 2 cosine theta, my answer would end up being 2. And I'll continue evaluating pi over 6 um, as the next input would be square root 3 over 2 for cosine, and then we get the square root of 3 once we multiply that by 2. For pi over 4, we get square root 2 over 2, multiplied by 2 is just root 2. For pi over 3, that's 1/2 for cosine, so half of 2 would just be 1. Then up at pi over 2, the cosine value would be 0. Anything multiplied by that would also be 0. Continuing next, we would have 2 pi over 3. The cosine value there is negative 1/2 multiplied by 2 would be negative 1. And then we would have 3 pi over 4, which is negative square root 2 over 2 multiplied by 2. We're kind of seeing a little bit of a pattern here now. 5 pi over 6, when we evaluate that, cosine of 5 pi over 6 would be negative 3 square root 2. So multiplying that by 2, we get negative square root 3. And then we also have cosine of pi, which is negative 1 multiplied by 2 is negative 2. For right now, I'm going to stop and plot those polar coordinates. Notice that all the values in pink are going to be your radius value, so that's how many rings we will count out. And then a couple of things that will be useful for us is that the square root of 3 is approximately 1.7. The square root of 2 is going to be approximately 1.4. That will help us when we're plotting those values. So on the polar graph, your first polar graph on your packet, you are going to have a theta value of 0 or 0 radians, and then count out 2 rings. So this is where the first little dot would go. Then we'll go up to pi over 6, which is that second tick mark on our page, and we'll go out 1.7. So 1.7, I guess, would be about here. Continuing that process, the middle tick mark in that first kind of quadrant, pi over 4, we're going to go out 1.4. Pi over 3, we're going to go out 1 ring. Then we have pi over 2, and that's going to sit right at the pole. 2 pi over 3, coming over to that second tick mark in the second quadrant, we're going to count back 1 ring, and that'll plot about here. Middle tick mark would be 3 pi over 4, and we'll count back approximately negative 1.4 this time. So 1 about here. And then we also have negative square root 3 is the next radius, so that's about negative 1.7. Opening up to 5 pi over 6, counting back about 1.7. And then last but not least, we have pi all the way over here, and we'll count back 2, and we're tracing over the exact same spot where we started. This is how we know when to stop. And we can connect that graph, and there is a not so beautiful, but picture or equation of a circle. You'll continue this process for that front page of your packet, graphing the other three equations at the top. And then at the very end, it asks you just to change the equation then to sign and see what happens. For that, you don't have to plot all the polar coordinates as precisely as we just did, just on your graphing calculator, and you can answer that question. So now that we're ready for the shortcut, you are able to do this a lot quicker by using some features in your calculator. First of all, you need to make sure your mode in your calculator is both radian and polar. And then you'll go and hit the button second window. That's where you get your table set. And we are going to change your table set here, the independent variable, to ask. This just means that you can type in whatever you want when you're looking at the table, so you can get all those theta values that are pertinent to us. Then we'll go over and we'll hit second y equals and we'll look at the table and we'll type in the values from 0 to 2 pi. Just a quick little note, the pi button is second caret. We'll have to hit these buttons in order to get pi. And then you'll notice that these are just the approximations. 0, this one's going to be pi over 6. That will continue all the way up to pi, just typing all those values in. And there is your inputs. And then in order to get your outputs, we'll kind of do a little bit of a live action here. When you're looking at that y equals equation on your graphing calculator, you would then type in 2 cosine, and theta, you're just going to hit the x variable button, and since we're in polar mode, that theta value will pop up. And then we can go back and look at the table this time, and we're seeing the same radius values that we just plotted by hand. So this way you just don't have to evaluate everything in your head. Feel free if you want to, but this is just a little bit of a shortcut for you. Then after you precisely plot these radius values on each of the graphs provided, I always recommend looking at your graph of your equation. You might need to play with your window a little bit. Here we go. And so my theta min is going to be 0. My theta max is going to be 2 pi. That's what that value is, but I'll type it in again just so you can see. And then it's a good idea to have this be a value, maybe pi over 24, so it just traces out a smooth curve. Pi over 12 would also be appropriate too. And then for our x mins all in our window, we're going to match what that graph looks like. So it looks like we've got -6 to +6. And we'll make that scale be 1, just like the graph displays. Your y min will also be -6, and your y max will also be +6. And then when we hit the graphing button, it traces out a circle. Now this is a little bit stretched, it's a little bit oblong because our graphing calculator kind of shows a rectangular screen. So if that bothers you, you can hit zoom square and it should trace out and look more circular for you. And there you have it. You'll continue to graph the equations in this packet, being precise with the ones that are listed at the top of the page, and then observing how the graphs change based on the constants in the equations. Good luck.